today, we'll be looking at this idea of an antiderivative. If we start with an original function and then produce a derivative of that, then the process is called differentiation. Now, if I do the reverse order, that is that I start from a derivative and go back to an original function, then the process is called antidifferentiation. Notice we've got some funny symbols going on here. Remember that f of x is the antiderivative of f prime of x, the derivative. And we can write it like this: f of x is equal to the antiderivative of f prime of x with respect to x. So this is just the x here, which just tells us that we're doing the antiderivative with respect to x, so we're interested in the x variable. And in 11 methods, it will always be the case, so there will be no confusion, but that's just the formal way that we write that. But we have this funny looking symbol here, which is just the antiderivative, and it's in fact called the integrand technically, but it just means that we're talking about the antiderivative or integrand. Some properties of integrals. So integrals are the words that we use to work out the antiderivative. So if we have the antiderivative of certain terms, then we can break that up. So if you could imagine the antiderivative of x squared plus 6x with respect to x, then we can break it up and just work out the antiderivative of the x squared and work out the antiderivative of the 6x and add or subtract them together. Also, if we have some kind of function f of x and there's a constant outside the front, maybe a 10 or a 4 or a -3, then what we can do is take out that constant and put it at the front of the integrand. And that will make the antiderivative process a lot easier to perform if we do take out the constant and put it at the front. Let's look at the process of working out the antiderivative. If I work out the antiderivative of a constant with respect to x, then that's going to equal the constant times x plus this new constant called c. If I work out the antiderivative of x to the power of n with respect to x, then what we do is lift the power up by 1 and then divide by that new power and add on c, which is an unknown constant. Please note that the power cannot equal -1. Also, we have this rule here. If we have the antiderivative of a linear factor raised to the power of n, then I have my linear factor and I raise it to 1 more than what the power was previously, and I divide by a, which is the coefficient of x in that linear factor, and the new power. I add to it the constant. This process here will be easier to see and understand with some real examples. Please also note, if we have a function and we take the antiderivative of it, we can write that it's equal to capital F of x. So capital F of x is the antiderivative of a particular function with respect to x. Okay, problem 1. Find the antiderivative of y equals 3x squared plus 2x minus 4. So there's my integrand symbol. So I'm the antiderivative of this expression here with respect to x. Look at the 3x squared. The power goes up by 1, so it becomes a 3. That 3 there remains. But I divide by the new power. So the new power is 3, so that's what I divide by. I have 2x. So I raise the power up by 1, so it becomes 2x squared. And because that's now a 2, I divide by that 2. Minus 4, that's just a constant, so that just becomes minus 4x. I also add on an unknown constant c here. I don't know what that is. I'll need more information to determine what that is. So simplifying, the antiderivative of 3x squared plus 2x minus 4 with respect to x is going to be x cubed plus x squared minus 4x plus c. Look at the process here. I've started with the 3x squared plus 2x take away 4. I've done the antiderivative to produce this cubic. And now if I take the derivative of that cubic, I'll get back to what I originally started with. Why on earth are we adding this c? Think of this situation. If I have f of x equaling x cubed plus x squared minus 4x plus 10, I'll get this as a derivative. If I now take a different f of x where the constant is negative 6 at the end, and then take the derivative of that, I'll get that as the derivative. Notice that these two are exactly the same. Doesn't make sense. We know that if we have f of x equaling the antiderivative of f prime of x with respect to x, then we're unable to work out, I need to cut that at the end of showing that the two derivatives are the same, and then get into an explanation of this line here. If I begin at this level, so 3x squared plus 2x minus 4, and work out the antiderivative of that, I've got no way of working out that I have a negative 6 on the end. In the same way over here, if I start at this and go backwards, I've got no idea and no way of working out that that's a 10. So what we do there is that we just add the c to it at the very end to show that there is some kind of constant there, but unfortunately we don't know what that is at this stage. If we had more information, then we could work out what that constant is, and later on you'll see some examples where we are able to determine the unknown c. Alright, just getting back to the problem 1 here. Remember we had to find the antiderivative of y equaling 3x squared plus 2x minus 4. And you can see the solution that we obtained by hand. Of course, we can make use of our CAS calculator as well. So I want to go Menu, Calculus, and this time I want to select Integral. Here's your integrand symbol. Later on we'll learn about terminals, but at the moment just leave these blank. In this box we're going to put the function. So our function is 3x squared plus 2x minus 4. So that's where the function goes. I'm going to find the antiderivative of that. And just over here, we need to let the CAS know what variable we are doing this with respect to. And we'll be doing it with respect to x. Sometimes in maths, we'll have multiple variables in a function, but you don't need to worry about that at year 11 or 12 methods. Hit enter, and we get our solution. Notice that it's almost exactly the same as what we obtained by hand, except for it doesn't refer to this plus c. So if you do find the antiderivative using this technique, you need to ensure that you add the plus c when you write your solution. Alrighty, so problem 2 here, we've got a series of different functions. We need to work out the antiderivative of each. Notice that this dx just means that we're doing it with respect to x. So for A, we've got the antiderivative of x squared on 4 with respect to x. Notice this x squared on 4 can be written as a quarter times x squared, and then with the quarter we can take that out the front of the integrand. So really we're looking at a quarter out the front of the integrand, and then we're taking the antiderivative of just x squared with respect to x. So what we do is with the x squared we lift the power up by 1, so that's x cubed, and we divide by the new power. But we always add on a constant to it. Now, we can just call it c, but in this particular case, I'm calling it c1. It's a very specific constant, just calling it c1 there. Notice that I've got all of this in brackets with the quarter out the front. If I now multiply the quarter through, I've got x cubed on 12 plus that c1, which is equivalent to this c1, over 12 as well. And of course, we end up with x cubed on 12, and then instead of calling this constant here, c1 on 12, I'm just going to call it the general constant c. B. We've got the antiderivative of x cubed to the power of 5 with respect to x. Using our index laws, we know that this will become x to the power of 15. And now working out the antiderivative, the power goes up by 1, so it becomes a 16, and we divide by the new power, and we add an unknown constant c to it. Question C. Fairly long-winded, but our first move is to make sure that it's in a format that we can work out the antiderivative. So our problem is here. We've got 1 over 3x squared. So I'm going to see that as being 1/3 x to the power of negative 2. So I'm going to bring up the x and then change the sign. So we've got the 1/3 x to the power of negative 2. So from this line here, it's easy for us to work out the antiderivative. X to the power of 5, so it becomes x to the power of 6 divided by 6. 3x squared, so that's going to become 3x cubed over the new power, which is 3. 4x, so it becomes 4x squared over the new power, which is 2 again. And here I've got myself x to the power of negative 2. If I lift that up by 1, then that's going to become x to the power of negative 1. So that's where I have my x to the power of negative 1. And I need to divide by the new power. So the new power is negative 1. If I'm dividing by it, so it's simply going to be 1 over negative 1. I've still got my 1/3, so that stays there, and there's my x to the power of negative 1. So the reason I've got this 1 over negative 1 is because the new power, when I lift this here, negative 2 up by 1, it becomes negative 1. The constant 8 is going to become 8x, and don't forget the general c. Tidying things up, then obviously that term there can simplify, this term can simplify, and this will simplify as well. I've got this x to the power of negative 1, and I can rewrite it so it's minus 1 over 3 to the power of x. That term there is exactly the same as this, as we know. If you achieve this line, 100% correct. Indeed, it looks a little bit confusing. You've got the antiderivative of 1 over the linear factor 2x plus 3 raised to the power 3 with respect to x. Our first move is to bring the bottom part of the fraction to the top, which means that we write it as 2x plus 3 and we change the sign of the power so it becomes negative 3. Now at this stage we have to make use of this rule here. The antiderivative of a linear factor raised to the power of n with respect to x is going to equal 1 over the coefficient of x, so the a is in front of the x, so the a is there. And then this n plus 1 represents the new power. So formerly the power was n. If we increase that by 1, it's n plus 1. So it's 1 over the coefficient of x multiplied by the new power. And then I multiply that by the linear factor, the ax plus b, and that's raised to the new power, which is just an increase of 1, and don't forget the constant. So we're at this stage here. The linear factor is 2x plus 3, and the power is negative 3. So it's 1 over the coefficient of x, which is 2, being multiplied by the new power. So negative 3 plus 1 becomes negative 2. I then have my linear factor, 2x plus 3, raised to the power, or the new power. So negative 3 plus 1 is negative 2, and there is my constant that I can't forget. Of course, 1 over 2 times negative 2 becomes a negative 1/4, and I have 2x plus 3 raised to the power of negative 2, and there's my plus c, of course. This line here is perfectly correct, but if I wanted to, I could bring this 2x plus 3 to the power of negative 2 to the bottom of the fraction and have it as a positive 2 for the power.